Questions 21 through 25 on the 2007 Grade 12 AMC 12B. The first 2007 positive integers are each written in base 3. How many of these base 3 representations are palindromes? Palindrome is a number that reads the same forward and backward. So first, a little introduction to base 3. It is known as the ternary system, and we, of course, always write numbers in base 10, right? But if you want to write a number in base 3, it's done as follows. First, it starts from right to left instead of left to right, and each number represents a power of 3. So 3 to the power of 1, 3 to the power of 3, 2, 3 to the power of 3, 3 to the power of 4, like that. Okay? And so on. Now, the number that goes in each of these blanks is either a 0, a 1, or a 2. And that's it. Can't use any other number. So, for example, I'll give you a few examples and you hopefully get the hang of this. First and foremost, what is 3 to the power of 0? It's 1. 3 to the power of 1 is 3. This is 9, 27, 81, 243, 729. So I'll give an example. Let's say we want to write 1, the number 1 in base 3. Well, the number 1, we would just put a 1 right there because that represents this value, which is 1. How about if I want to write 2 in base 3? Well, instead of putting a 1 there, I would put a 2 there. Okay? So this is 1 in base 3, this is 2 in base 3. So far it's the same, but what about 3 in base 3? Remember, I can only put either a 1, a 0, or a 2. So what I do is I put a 0 here and a 1 here, because this 0 tells me that I don't include that, but this 1 tells me that I include this once. So that's how I get 3. So the 3 written in base 3 is 1, 0. Okay, I'll do a few more. Let's do some larger ones just to give you a little bit of a hang of how this works. Let's try, let's say, 15. Well, 15, let's see, how can I make that in base 3? I'm going to include 9, and now I've got 6 more. So that will give me 6 more, 2 times 3. And then this is 0. So 15 in base 3 is 1, 2, 0. You got it? I'll do a couple more. Some of you already know what base 3 is, but those of you who don't, hopefully this will help. How about 25 in base 3? Okay, well, it's 9. This is too big, so I'm going to use 9. I use 2 of them, so that will be 18. Now I still got 7 left, so I'm going to need 2 of these. That's 6. I've got 1 left, so there you go. 2, 2, 1. That's 25 written in base 3. I'll do one more. Let's try 30. Okay, 30 in base 3. Well, I'm going to include this guy right here, the 3 to the power of 3. Now I've got 3 left over, and I can just use that one. So 0, 0. This is 30 in base 3. Okay, so that's a little bit of an introduction to base 3. So what they're saying is they're writing all the numbers from 1, 2, 3, all the way until 2007 in base 3. And they want you to see how many of them are palindromes. All right, perhaps we can do this. So we'll make a little list. First and foremost, the number of digits of my base 3 representation. Base 3 number of digits. And then, of course, how many palindromes are there? And finally, I'm going to list them here. Now, before I get started, keep in mind that this list only goes up to 2007, correct? So that's the biggest number. So that tells me the range. So I want to convert 2007 to the base 3 representation, and that will give me an idea of how far I need to go in this list. All right, let's do this. I'm probably going to need to use the 729, and I think I can squeeze that in twice. So there you go, 2 goes there. And then I think I can put in 243 twice. And then after that, I have 63 remaining, so I have less than 81. So how many times do I want to include that 27? I can probably include it twice. And then I've got a 9 remaining. I just put 1 there. And there you go. 2, 2, 0, 2, 1, 0, 0. This is the base 3 representation of 2007. And this is very important because that tells me that I don't need to go more than 7 digits. This is the representation of 2007 in base 3, and as you can see, it has 7 digits. So that's as far as I need to go in this list. So in my list, I'm going to look at 1, 2, 3, 4, 5, 6, and 7. That's it. All right, base 3 representation of a 1-digit number. Well, there's only one way of doing that. That's 1 and 2. And both of these are palindromes. I mean, they're just single digits. Read backwards and forwards, obviously, it's the same. So 2 of these guys. How about base 3 representations where you have 2 digits? Well, 1, 1 and 2, 2. Can't have 0, 0 because that's not a number, right? I mean, it is, it's 0, but our list is from 1 to 2007. So I got 2 of these. Okay, so far things are kind of easy. How about 3 digits for my base 3 representation? Okay, a palindrome would be 101, 111, 121, 202, 212, and 222. These will be palindromes, so 6 of those. Okay, things will get complicated very quickly here now. The first few were relatively easy. How about 4 digits? Okay, 4 digits shouldn't be too bad. 1001, 1111, 1221, 2002, 2112, and 2222. These are the only palindromes I can make with base 3 representations of numbers. So there are 6 of those. Okay, so far we're doing very good here. Now we get into 5 digits. Okay, 5 digits. All right, 10001, 10101, 10201. Okay, 11011, 111, all ones, 11211, and then 12021, 12121, and 12221. The reason I'm able to do this quickly is not because I'm, superior when it comes to base 3 representations. I'm cheating a little bit. I'm just copying these. If you notice, all of these guys that I put there are exactly the same as that. You see what I mean? The middle 3 digits. So I cheated a little bit. Well, it's okay. I cheated off myself. No problem. So how many did I get? Well, I got 9, but this you can list twice. Why? Because the first digit and the last digit can be 2s as well. So I want you to be convinced of that. All the middle digits can be the same, but each of these can be written with 2s instead of 1s. So instead of listing them all, I just want you to be convinced that I can do the exact same thing with 2s. So I got 9, but the total is actually 18 because I can do the same list again with 2s. All right, so I am now up to a pretty decent list here. Now we get into 6-digit with regard to my base 3 representation. All right, 6 digits. So 1, 0, 0. It's 4 digits in the middle this time. So 1, 0, 1, 1, 0, 1, 1, 0, 2, 2, 0, 1, and then 1, 1, 0, 0, 1, 1. Again, I'm cheating. I'm just putting in these guys in terms of the middle 4 digits. 1, 1, 1, 1, 1, 1. And then 1, 1, 2, 2, 1, 1. And then 1, 2002. I hope you see that I'm just following that pattern. And then 1, 2, 1, 1, 2, 1. And then 1, 2, 2, 2, 2, 1, like that. And very similarly as before, we can understand that all of these can be done the same way, but instead of 1s as my first and last, I can put 2s as my first and last number. So since there's 9 of those with 1s, there's another 9 with 2s. So that total is 18. So now we come to the very last case, which is 7 digits. All right, 7 digits. So here we go. 1, and then 5 digits in the middle, like that. 1, 0, 0, 1, 0, 0, 1. 1, 0, 0, 2, 0, 0, 1, like that. And then 1, 0, 1, 0, 1, 0, like that. Then 1, 0, 1, 1, 1, 0, 1. 1, 0, 1, 2, 1, 0, 1. 1, 0, 2, 0, 2, 0, 1. And then let's see here. 1, 0, 2, 1, 2, 0, 1. And finally 1, 0, 2, 2, 2, 0, 1. Now at this point, these guys had zeros in terms of their first and last digits, right? But the remaining, I can just copy these guys for those middle flat 5. So instead of writing them all out, just keep in mind that those guys will be used. So there's 9 of those, right? But in fact, there's 18 because that list can be reproduced with 2s instead of 1s as my first and last. So there's an additional 18 of these where you have 1s on both ends, but the middle 5 numbers are these 18. Got it? And then this full list can be done exactly the same with 2s as my first and last digit. So I hope that makes sense. So that means you got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 plus 18 is 27. 27 times 2 is 54. Okay, so now let's add up this 2, 2, 6, 6, 18, 18, and 54. My grand total is 106. So let's go back and look at the answer choices. 106 is not one of the answers, and I'm happy that it's not, because if it was, most people would just circle it and then move on and get it wrong. The reason it's not is because everything that I listed lists all the base 3 representations, right, that involve either 1 digit, 2 digits, 3 digits, all the way up to 7 digits. But I'm only going up to 2007. There's certain numbers that I have included in this list here that are greater than 2007. So I have to get rid of those. And that's where my base 3 representation of 2007 comes in handy. So 2202100, that's as high as I can go. I can't go any more than that. So obviously some of these base 3 representations that have 7 digits are a number that's greater than 2007. Okay? So first let's write my 2007 in base 3. It was 2202100. Now I have to get rid of the numbers that are greater than 2007. that are palindromes. Okay, no problem. The first one that immediately comes to mind is the one where it's all 2's. That is definitely greater than 2007. All right, just keep going here. 2, 2. How about if I have 2, 2, that's still a palindrome? 2, 2, 1, that's also a palindrome. That's greater than 2007. And then I can also make one with a 0 in the middle, like that. Okay, keep my 2, 2's, but how about let's add 1 this time? 1, 1, 1. That's also greater than 2007. And then 1, 1, 0. That's also going to be greater than 2007. And then 2, 2, 2, 2. And I think if I put 0, 2, 0, that will also be greater than 2007. So that's 6 palindromes that are greater than 2007 that I need to subtract from this list. So 106 minus these 6 gives me 100, and that is how many palindromes are between 1 and 2007 when written in base 3. So the answer to number 21 is 100, which is choice A. Two particles move along the edges of an equilateral triangle ABC in the direction A to B to C, then to A, starting simultaneously and moving at the same speed. One starts at A and the other starts at the midpoint of BC. The midpoint of the line segment joining the two particles traces out a path that encloses a region R. What is the ratio of the area of R to the area of ABC? So here is our equilateral triangle. Here's A, B, and C. And the first particle starts at A, so we'll denote that right here. And the second particle starts at the midpoint of BC, so approximately here. And they're going in this direction and that direction. And then eventually, they will form this region R. How is that region formed? Well, as you trace that midpoint. So let's just start looking at the midpoints. First and foremost, when they are starting, there's going to be a midpoint between their two positions, and that is approximately right, I'd say about here. That's the midpoint, approximately. And then let's move them somewhere, and let's make another midpoint. So let's say this particle moves halfway across to C. That means A moves halfway across to between A and B. Now they are there. Again, we have to figure out their midpoint. So that's the straight line connecting them. Their midpoint will be approximately here. Got it? And let's keep going here. Let's say now this particle moves again to, say, here, halfway between A and C. This particle moves again the same distance because they're traveling at the same speed, right? And then now this particle is here, this particle is here. Let's draw the line that connects them. And therefore, let's draw the midpoint. And that midpoint is approximately here. So as you can see, if you keep doing this, it's going to form a triangle. Now, I think that's probably a difficult part because I wasn't sure this region. They just say region. They don't say encloses a triangle R. I mean, what if it's a circle, right? It could be. Who knows, right? But good news is that if you keep doing this and you've got the patience to do so, it forms this triangular region like that. So that triangular region that I just drew in red is R. And what we have to do is figure out the ratio of the area of R to the ratio of the area of the whole ABC. Okay, I can probably do this, I hope. All right, so first what I'm going to do is just concentrate on ABC, the big guy. Okay, once I concentrate on that, things will be a little bit clearer. So I'll draw this equilateral triangle again. All right, now first and foremost, they don't give us any distances, right? They don't say anything in terms of the side length. So because we're looking at a ratio, it won't matter what we call the side length. In the end, everything cancels out. So if I call it x, the x would cancel. But instead of using x's and making it confusing, let's just use numbers. Let's just say the side is 2. Okay, it's perfectly fine to do that in this question. Now I want to figure out the area of this equilateral triangle. Okay, draw a perpendicular from the top to bottom, like that. And that will represent a right triangle. And I'll call this H. So the area of ABC, is 1/2 base times height. Well, the base I just labeled 2, and the height is h. I've got to find a numerical value for h. No problem. It's an equilateral triangle, so that's 60 degrees. This perpendicular chops that 60 degrees in half, so that becomes 30. This is a 30, 60, 90 triangle. The ratios of a 30, 60, 90 triangle are 1, 2, and root 3. Now, this whole thing was 2, so the numerical value of that distance is 1. So that means if you look at the ratio, h over 1 is equal to root 3 over 1. So h is just root 3. So the area is 1/2 times base times root 3, and this is just root 3. All right, so we've relatively quickly found the area of ABC. Now I have to find the area of this region R, right here. And the good news is that it's very similar, but I have to first figure out a few distances. Now this h here we found was root 3, correct? Now concentrate on that first midpoint, that first red dot. It's the midpoint between that position and that position, correct? So from top to bottom is root 3. So therefore, from here to here, since that's the midpoint, is root 3 over 2. So I'll just write that in there, root 3 over 2. That's this distance right here. Okay? In a very similar way, you can show that the distance from here to here is also root 3 over 2. Why? Because this was the midpoint when the two particles were here and here, correct? So this whole distance is exactly the same as that distance, which is root 3, as I figured out over here. So therefore, the distance from there to there is also root 3 over 2. All right? Now, what I need to do is figure out this distance right here, from here to the base. That is very important because that allows me to figure out the distance from here to here inside that red small triangle. So how do I do that? Well, I just drew a perpendicular, so that's a right angle. And very similarly, I use angles. This whole thing is 60 degrees. This line chops that in half, so that's 30. This is 90, I just drew that, and therefore this is 60. So again, 30, 60, 90 triangle. Ratio of the sides are 1, 2, and root 3. So if I want to find this line, let's call it, we can call it x. So we've got, let's see here, x over root 3 over 2 is going to be, in terms of ratios, 1 over 2, correct? So that means x is equal to root 3 over 4. Root 3 over 4. So perfect. Now I can figure out my distance from top to bottom inside that triangle right there, this top to bottom distance. How do I figure that out? Well, the full distance from top to bottom was root 3. Okay? Let me just label that. This distance that I'm trying to figure out, I'll just call that h. H for height. Well, I'll call it small h. I don't want you to get confused with that big H over there. So let's call it small h. Small h is basically, first you look at that full distance top to bottom, which is root 3. Subtract from that this guy, which is root 3 over 2. And we also need to subtract this distance, which I just figured out was root 3 over 4. Okay? And if you do that, you get h is equal to root 3 over 4. Okay? So we are almost done. To figure out this triangle's area, I've already got the height. I just have to now figure out the base. So I'll draw that triangle again, but I'll draw it a little bit separately because first of all it's too small, and second I don't want to mess up that diagram. So this small region R, I've bloated it up a little bit, and let's label it now. First I'll draw that perpendicular top to bottom. Now I just figured out that h was equal to root 3 over 4. Now I need to figure out this base in order to figure out the area of that small r region. Okay, how do I do that? Well, again, exact same thing that we've been doing over and over. 60 degrees here, 30 degrees here. The ratio of the sides, of course, as before, are 1, 2, and root 3. So I'll call this side b over 2 since that whole thing represents the base. So that means h over b over 2 is equal to root 3 over 1. So h is equal to root 3 over 2b, correct? And h we know is root 3 over 4, like that, root 3 over 2b. So therefore b, if you solve for this, is just a half. So that's b over, yeah, that's b basically. And that's it. So now I can figure out the area of the small region R. So R is really just the area of this small triangle. 1/2 base times height. That is equal to 1/2. The base is 1/2. And the height is root 3 over 4. So that is root 3 over 16. And ABC I had figured out earlier was root 3. And I have to figure out the ratio of R to ABC. So the ratio of R to ABC, R is root 3 over 16, and ABC is root 3. So invert and multiply, and you get 1 over root 3, and this just leaves you with 1 over 16. So 1 over 16 is the answer to our question, and therefore number 22, the answer is A. How many non-congruent right triangles with positive integer leg lengths have areas that are numerically equal to 3 times their perimeters? So we have some triangle. We don't know what the size is. We don't know anything about it. The only thing we know are the side lengths. We can label them A, B, and C. And we do know that it's a right triangle. And as always, we can figure out the area as 1/2 base times height, which in this case would be AB. And the perimeter is A plus B plus C. Now they tell us in the question that the area is equal to 3 times the perimeter. So that means 1/2 AB is equal to 3 times A plus B plus C. Okay? And then also, because it's a right triangle, we know that A squared plus B squared is equal to C squared. So these are our equations. Most of them have been given to us from the question, and we have to somehow figure out all the possible triangles that satisfy all of this. Okay, where do I go from here? All right, well, first thing is I fiddle around a little bit with this some of the more common algebra, a plus b squared is a squared plus 2ab plus b squared, right? You know that. And the reason I did that is because a squared and b squared equals c squared, and 2ab, well, ab, I've got something in that form, so that kind of came to mind immediately. So a squared plus b squared, I'll substitute c squared because I need c squared somewhere. And then 2ab, well, 2ab basically is going to be very similar to that, because this gives me ab is equal to 2 times 3a plus b plus c. Correct? So 2ab looks like 2 times ab, which is 2 times 3 times a plus b plus c. And then this we can just leave it like that for now. Okay. Bring this over to the other side. A plus b squared minus c squared is equal to 4 times 3, 12 a plus b plus c. And then this left side factors. We get a plus b minus c, a plus b plus c. And the good news is that this a plus b plus c cancels. So all you're left with is just a plus b minus c is equal to 12. Or you can write it like a plus b minus 12 is equal to c. Okay? So that basically tells me that if I know a plus b, or if I know the values of a and b, I can calculate the value of c. This is going to perhaps help us. I don't know. But I just wanted to put that in there. All right, now let's get to the heart of the question. We have to figure out these triangles. How many of them are there? So to do that, I want to work really with this equation right here. That will allow me, hopefully, to figure out how many triangles there are. So I've got AB is equal to, I believe it was 6 times A plus B plus C. Correct? So that means we've got 6 times A plus B, but C, if I look at that equation, is equal to the square root of A squared plus B squared. Right? And that's equal to AB. Okay? So far, no tricks. If there is any trick, I will let you know. I'll write it in red. But so far, it's just straight algebra. Now let's bring everything over. AB minus 6A minus 6B. And this leaves me with just 6A squared plus B squared on this side. And then definitely get rid of this radical, square both sides. 36A squared plus B squared, like that. If you square that side, you get AB minus 6A minus 6B times AB minus 6A minus 6B, like this. Okay, expanding this big long equation. Now let's collect like terms and let's see what happens. I see an AB will probably factor from everything. So this gives me AB minus 6A minus 6B minus 6A plus 36 minus 6B plus 36, like that. And the good news was that this 36A canceled with that, and this 36B canceled with that, so we're left with a 0 here. Okay, so far so good. No tricks so far. Now let's collect like terms, and we do that, and we get AB, and we get AB in here, minus 12A, minus 12B, plus 72. Okay, so far, this is where we have reached. Does this help us? Does this look like it's going to help you? Well, now is where we have to do a little bit of trickery. Nothing super extreme. First, you have to recognize that AB cannot be 0, right? A and B represent the sides of a triangle, so neither of them can be 0. So because neither of them can be 0, this must be equal to 0. So that means AB minus 12A minus 12B plus 72 is equal to 0. Now, the magic trick is to add 72 to both sides, like this. The rest stays the same. What that does is allows you to factor this in a way that will be beneficial. This now becomes AB minus 12A minus 12B plus 144, and that equals 72. And now we can factor this. This becomes A, B, 12, 12 minus minus. All right? This is the point where you can figure out values of A and B. Okay? Now, how do you do that? Well, basically what you do is you look at the prime factors of 72, and then you make each of these equal to one of those factors. So for example, let's make a list here. A minus 12 and B minus 12, correct? And when you multiply them, they've got to equal 72. So, what two numbers can be multiplied to give 72? Well, 1 and 72, 2 and 36, 3 and 24, 4 and 18, right? 6 and 12, 8 and 9. And at this point, it would be the same. It would be 9 and 8, and those would give you pretty much the same triangle. So let's go with this. So A minus 12 is equal to 1. So that means I'll draw that over here, values of A and B. A, B, and we'll draw C. And remember, C was going to be equal to A plus B minus 12, right? I did that for a reason. It's going to be equal to A plus B minus 12. Okay, this will allow me to figure out the entire scenario. So here we go. A minus 12, if it's equal to 1, that means A is 13. B minus 12, if it's equal to 72, that means B is equal to 84. And C is equal to A plus B minus 12, so that would be 13 plus 84 minus 12. So we got one triangle. That's great. That satisfies all of our conditions. Let's go with the next one. A minus 12 is 2. That means A is 14. B minus 12 is 36. That means B is 48. And then C is going to be 14 plus 48 minus 12, and that is 50. Next one, A minus 12 is equal to 3. That means A is 15. B minus 12 is equal to 24. That means B is 36. And C, therefore, will be 15 plus 36 minus 12, which is 39. Okay, next one, A minus 12 is 4. That means A is 16. B minus 12 is 18, so that means B is 30. And therefore, we've got 16 plus 30 minus 12, and that gives me a value of 34 for C. A minus 12 is equal to 6, so that means we have 18 for A. B minus 12 is 12, so that means that's 24. And therefore, C will be 18 plus 24 minus 12, which is 30. And finally, A minus 12 is 8, so that means we have 20. B minus 12 is 9, so 21. And therefore, 29 will be the value for C. So how many triangles did I get in this very cool question? I got 6. Great. So number 23, the answer is 6, which is choice A. How many pairs of positive integers AB are there such that the greatest common divisor AB is equal to 1 and A over B plus 14B over 9A is an integer? The first step in this question is to let A over B equal to some variable, and I'll just use x. So that makes this equation x plus 14 over 9, 1 over x, right? And they tell me that that is equal to some integer. So this is my equation. This is what I'm going to have to work with, and that's the only thing they give me. No other information is given. Now this part just means that at the very end, when I get a value for A over B, I'm going to have to reduce it to lowest terms. That's the only thing that means, but that doesn't really help me that much. Okay, let's proceed with this. First thing is get rid of this terrible fraction. So that gives me just x squared 14 over 9 and x. Put everything on one side. X squared minus nx plus 14 over 9 is equal to 0. This is a quadratic equation. I'm going to have to use the quadratic formula, but first I'd like to get rid of that 9, multiply through by 9, and I will have 9x squared minus 9 plus 14 is equal to 0. Now we can use a quadratic formula to figure out x. X is going to be minus b, so that's minus 9n, plus or minus the square root of b squared minus 9n squared minus 4ac all over 2 times a, which is 9. So this is 9n plus or minus 81n squared minus 504, all under the square root, all over 18. That is 9n. I can factor out a 9. So that brings the 3 if I take it out of the radical. And what's left is 9n squared minus 56 all over 18. And this, if you break this up, it'll be just n over 2 plus or minus 9n squared minus 56 over 6. And that is equal to x. And let's remember that x is equal to a over b, like this. Okay? So this is what we have gotten down to. This. Now let's talk about this. A over b is basically, if you read the question, a fraction containing two positive integers, right? So it could be 4 and whatever, right? 2 and 3, 1 and 7, I don't know. So this is basically a rational number, and that is equal to this. So the only way this can be a rational number is if we somehow get rid of this square root. We can't have a square root in the answer because that would not make it rational. So the only way that square root disappears is if what is inside the square root is a perfect square. So that is perhaps the heart of the question. I think it is. So 9n squared minus 56 is a perfect square. It has to be in order for this to be a rational number, the fraction involving two positive integers. So 9n squared minus 56 therefore is a perfect square. I'll let that perfect square be represented by m squared. Rearranging this, we get 9n squared minus m squared is equal to 56. And very similar to what we did previously in the question before and many other questions, we have to now make a little bit of a table. First, we have to factor this. So we got 3n, m, minus plus. And then we got to make a table 3n plus m and see what we get. Here we go. And how are we going to do this? Well, based on the fact that when those two numbers are multiplied, they have to equal 56. So, and this, of course, is greater than that, right? 3n plus m has got to be greater than 3n minus m because m is an integer. Okay. All right, here we go. So my possibilities are 1 in 56, 2 in 28, 4 and 14, and finally 7 and 8. These are the numbers that, when multiplied together, give me 56. So let's work with this now. Let's work with the first one here. If 3n minus m is equal to 1 and 3n plus m is equal to 56, add them and you get 6n is equal to 57. N is equal to 9.5. Well, that's no good because n represents an integer. So that won't give me an integer solution. All right, let's move on. The next one. 3n minus m is equal to 2. 3n plus m is equal to 28. 6n is equal to 30. N is therefore equal to 5. Great, we got one value of n. Let's do the next one here. 3n minus m is equal to 4, and 3n plus m is equal to 14. Adding, we get 6n is equal to 18. N is therefore equal to 3. Okay, that's great. And then let's see what the last one gives me. 3n minus m is equal to 7. 3n plus m is equal to 8. If you add, you get 6n is equal to 15, and therefore n is equal to 2.5, and that's not an integer. Okay, no problem. I got 5 and 3 as my possible values for n. All right, let's go back and use this equation to figure out a over b, using first n equals 5, and then I'll use n equals 3. So for n equals 5, what do I get? I get a over b is equal to 5 over 2 plus or minus 9 times 5 squared, which is 25, minus 56, all over 6. So that looks like 5 over 2 plus or minus, let's see here, that's going to be equal to 13. 13 over 6. So this gives me values of 8 over 6, 28 over 6. And 2 over 6. If I add those fractions. Then I've got to reduce this to the lowest terms. That's the key to the question. And 14 over 3 and 1 over 3. Okay. So that takes care of n equals 5. And then the next one was n equals 3, right? So I've got to do this again for n equals 3. Okay. Using this same equation. So for n equals 3, that's going to give me a over b is equal to 3 over 2 plus or minus n equals 3. So 3 times 3 is 9. 9 times 9 is 81 minus 56. All over 6. So that is 3 over 2 plus or minus 25 square root 5 over 6. So this gives me 14 over 6 or 4 over 6. And that in lowest terms is 7 over 3 and 2 over 3. So the number of possible values for a over b, I got 14 over 3, 1 over 3, 7 over 3, and 2 over 3. So I got 4 possible values, 4 possible pairs. And therefore, number 24, the answer is 8. points A, B, C, D, and E are located in three-dimensional space with AB equal to BC equal to CD equal to DE equal to EA equal to 2. Angles ABC, CDE, and DEA are equal to 90 degrees. The plane of ABC is parallel to DE. What is the area of triangle BDE? Let's draw this the best that we can, the best that I can, to try to explain it. So I'm just going to use the coordinate plane X, Y, Z. And I hope this will make sense. There's many ways of doing this question. There's no right way, there's no wrong way, in the sense like, as long as you understand it. So first, without making it too complicated, I'm just going to take it one step at a time. First, I'll just draw AB, this guy right here. And I have no idea, so I'll just put it here. Okay, that's AB. Then I'm going to draw BC. Now, they tell me that ABC is 90 degrees. So that tells me that BC is probably something like this. So before I move any further, let me label that. A, B, that corner right there, and C. And I'll put in that 90 degree. Okay, so far so good. You're with me? Following? All right, we've drawn what? AB and we've drawn BC. Now let's draw CD. Where is CD? I have no clue. But they tell me, did they tell me anything? Well, they tell me that CDE is 90 degrees right there. Okay, so CDE. All right, D perhaps is here, and then E perhaps is here. If that is the case, this is D, and this is E, and they tell me that CDE is 90 degrees. So that means this angle here is a right angle. Okay, so far I think I'm okay. Let's keep going here. Next I got to draw, I've drawn so far CDDA. Okay, I only have one left. EA. Well, EA is obviously right here, the connection between these two guys. All right. And they tell me that that angle, DEA, is also 90 degrees. So DEA is 90. Okay, looking at this, it looks to me as if this is kind of like a box. Perhaps. Like, I don't want to get anything confusing here, but you see how this is sort of like a box? And how this is sort of... Does that make sense? All right, so what do they want me to figure out? The area of BDE. BDE, that triangle. Okay, so B, first of all, I have to join it to D, and then BDE. So this triangle, they want me to figure out that area. Okay. Well, that should be relatively simple. Why? Because I believe that this angle between here and here is a right angle, like that. Okay, don't get confused. I drew a line between B and D, and now I'm talking about this angle between this line and this line. Okay, so that means I need to figure out the sizes now. They tell me that AB is 2, BC is 2, CD is 2, DE is 2, and EA is 2. Okay? Now, if this line is directly, above this line, the way I've drawn it, right? That it must also be 2. And if that's the case, then that means that this is an equilateral triangle. So this angle, even though it doesn't seem like it, is 60 degrees. That's got to be 60 degrees. This has got to be 60 degrees. Okay, that's the only way this would match. So we are now down to the final step, which is figuring out the area of BDE. Well, it's just going to be 1/2 base times height. Let's see here, BDE. This is the base, and that's 2. And the height is from there to there, which is also 2. And therefore, this is going to be 2 times 2, 4, divided by 2 is 2. So the answer to number 25 is C.